Now we continue our investigation of Taxicab geometry. We will give some examples. Let's have the easiest thing in here. So let's have these points A 1 0 and B is minus 2 2. Okay, in our case we can compute the distance by hand. Okay, here, so it's 2 1 and 2. The distance is 5 units between A and B. The difference in absolute value of the x distance is this one here. Okay, so that's 3 units, and the difference in absolute value between the y's is 2. And this gives us that the distance between A and B is 5. So in this example, the distance is 5. Okay, let's make it clear here. This is 3, this is 2. Okay. Next, we can see that the Euclidean distance is different. Okay, so if we compare the Euclidean with the Taxicab, the Euclidean is gonna give us the, let's say, between 1 and the square root of 1 minus 2, which is 3 squared, plus 0 minus 2 squared, which is 2, that means 2 squared is 4. And we have the distance is 9 plus 4, which is the square root of 13. And in this case here, we see here that this is 3 point something. I think 3.7. It's less. Okay, that's why we tend, instead of going from this point A to B using the Taxicab, we tend to use the Euclidean, okay, because it's always less. But for us, when you are taking a taxi, you have to go this way. You will be charged for this distance, not for this one here. Okay. Another thing is that going from A to B is the same as going from B to A. Okay, to see that, compute it. Or we can use the definition to prove it. We know that the distance between A and B in Taxicab geometry is x1 minus x2 plus y1 minus y2. Okay, and it's the same as x2 minus x1 plus y2 minus y1. That means going from A to B is the same as going from B to A. Okay, this is one property of the distances. Okay, and the next thing that we need to see is that if we have A and B on the same line, that's when we get the minimum distance. Okay, so here to see that, let's give one. It's not a proof, but let's just fix the idea here. Okay, here, let's say this is my point A, this is my point B. These two guys are on the same line. So a person wants to go from A to B using the Taxicab geometry, and another one wants to go from point B to A. Okay, they will have to drive or to pay for the same distance. Okay, now if we use the Euclidean geometry, we see, let me use this formula here. Okay, here, so the y is the same. Here for A and B, they have the same y, and therefore this is 0. Okay, and this is 0, and therefore we get the distance between A and B is the square root of x1 minus x2 squared, and this is x1 minus x2 in absolute value, and this is the Taxicab. Okay, so this is the distance between A and B. Let's use T here, and let's use E here. So to mean that this is computed using the Euclidean distance, and this is computed to using the taxicab geometry. So we see here that the two are the same if my points are on the same horizontal or vertical line. And this is the only case when these two are the same. Okay? Remember, horizontal or vertical, the only case where the two geometries are the same. Okay, next we're gonna see how circles look alike in this geometry, and after that we're gonna compute pi. Thank you very much.